Let's see how we could approximate film grain in Blender. I have already imported this image. I'll be using the world shader, looking through the camera and plugging the window coordinates into the image. By default, we'll get this repeating pattern. We can do Ctrl B to set the render region, but because it's repeating, we get this artifact at the edges. So we can change this to extend, for example, and it's fixed. Now to achieve this crystal-like structure, the most obvious way is using Voronoi. So we'll actually modify the coordinates to sample the image at the various cells, and then based on the sampled value decide which cells will be black and which will be white. So let's do Voronoi. If we look at the position, it looks basically the same as the input, but through these cells they are kind of stretched with the resolution, right? So we'll need to compensate this with the aspect ratio. So to get that, let's do divide, and we'll do x divided by y. You could just copy this as a new driver and paste it here, but I will do hashtag to start a new driver manually and type in whatever you would when making a Blender script. So let's do bpy.context scene render resolution underscore x. You can copy it here, but start with hashtag again. Let's make it y. And now we have the aspect ratio. Let's plug it into combine XYZ, make x 1. And now this value is larger than 1, so we'll need to actually divide by this vector. And you can see it's nicely uniform, but because we are stretching the coordinates, we need to take them back before plugging it into the image. So let's do multiply now by the same vector, and let's see if we increase the scale. We have basically the original image but sampled through Voronoi. Let's make it black and white. And the technique is basically to compare these sampled values with a random value per cell. We can get that random value through this color output. Let's separate it and use the x-axis, although it doesn't matter, of course. Let's do the sampled value greater than x. And if we increase scale even more, we get something that looks like film grain. Now we can make this a node group, although unfortunately we don't have an image socket, so we'll do just this. Let's name this coordinates and random. Let's clean this up a bit. Right, we can pass the scale outside, but if we want, we could actually calculate the scale based on the sensor size and the grain size. I mean, it depends on the sensitivity of the film, but let's say it's like 1 micrometer each. So let's see, the scale basically represents the frequency or the amount of cells per unit. If we, for example, make the randomness 0 and do 4, you can see it's sort of 4 cells across. So let's make a value which will represent the single crystal size. which is supposed to be around 1 micrometer. You can use scientific notation, so let's do 1e negative 6, which should be 1 micrometer. If we do 1 divided by the grain size, this should be the number of grains per 1 meter, but of course the sensor is much smaller than that, so we can do, let's say, 8 millimeters, 0.008, and in theory this should be correct. So let's actually let's do it like this. Let's make these into input group inputs. This will be sensor size starting from 0, and this will be the grain size. We can do Ctrl J to combine these. I think this is a new addition to Blender. Alright, so we have this. What else do we need? Oh, this is actually static right now, so if we wanted to apply the... Oh, I forgot to turn up the randomness again. If we wanted to apply this to video, we of course need to change the seed for each frame. Currently it's static, so we could add some number to this. It's actually three-dimensional Voronoi by default. 2D could be more performant, but we can take advantage of the third dimension for changing it in time. So let's do combine XYZ again, and we'll need the current frame number. So let's do value, start a new driver again, so hashtag, this time frame, and we can see it changes with the playback handle. Let's use Z-axis, and now we get different pattern every frame, which is perfect. Let's see, I think that's about it actually. Let's imagine it's a really coarse grain to get a better feel for it. Now, the reason I did this in the shader and not the compositor is because when the grains are really small, like let's say smaller than the pixel, there will be some problems in the compositor because it's sampling basically once per every pixel. And so you could fix this by upscaling the image, making the Voronoi and then downscaling it, but it's just too much trouble, so it's easier in shader this way. Let's name the group film grain, and I think that's it. Bye.